All right, let's look at this example of an orthogonal matrix, and we're going to try to figure out what kind of either a rotation or a reflection. All right, so first I'm going to look at the its determinant, right? In this case, we can either expand it along first row or third column. So let's do it along the maybe a first row. All right, so you have a 0 and a 0 and 1, so which is kind of convenient. So the first two term will be 0. Then you have 1 times the submatrix, the determinant of submatrix. So you strike out the first row and third column. So it's going to be a negative 1, 0, 0, negative 1. So we get this. So negative 1 times negative 1 minus 0 is going to give you positive 1. All right, so which means that it's going to be a rotation. If it was negative 1, then it'll be a reflection. All right, so let's try to find the axis of rotation. So we're trying to find the direction vector of the axis. So since if the vector is sitting on the axis, the rotation would not change that vector. So let's try to find a vector that is not affected by this matrix. So we can set up this equation here. You apply matrix M to this vector A, comma B, comma C. You get exactly the same thing as the original A, comma B, comma C. All right, so if you write this as an equation format, then C has to be equal to A, negative A has to be equal to B, and negative B has to be equal to C. All right, so I'm going to do maybe put 1 for C and A, and then B has to be negative of that. So the simplest vector we can come up with would be 1 comma negative 1 comma 1. So this is the direction vector of the axis of rotation. All right, so we have the axis, and how about the angle of rotation? Right. So by observing, finding m squared and m cubed and so on, then we found out that the m cubed is going to give you identity, which means that 3 rotation gives you a 360-degree rotation. So we know that the angle of rotation is going to be 360 divided by 3, so which gives you 120, either in a positive direction, which is the counterclockwise, or the negative direction, clockwise. All right, so we need to figure out clockwise direction or counterclockwise direction. So we're going to make this following observation. So we're going to start with vector I, 1, 0, 0. And if you apply m to it, you're going to get negative vector j, right? Then after that, if you apply another m, you're going to get a vector k. All right, so which way is it rotating? All right, so let's try to visualize using GeoGebra here. All right, so here is the direction vector of the axis of rotation, so which is 1 comma negative 1 comma 1, which points that way. All right, so start with vector I, which points this way. It's going to go to negative j, which goes this way. And then after that, another application of m gives you a k vector. So you can see that from here, send it to there, and send it to there, here, and, and here, and here, right? So you can see that it's rotating clockwise about this direction vector. So it's going to be clockwise is a negative direction, so angle of rotation would be negative 120. So we know that therefore we have m is a rotation about the direction vector 1 comma negative 1 comma 1 by negative 120 degrees. Right? That's it. I hope that this was clear.